Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing how to solve quadratic equations by factoring. So in the last lecture we discussed at the end of it the zero product property. And the cool thing about the zero product property is if you had multiple factors equal to zero, you could set each of those factors equal to zero and then solve. So that led us to believe that factoring might be a reasonable way to solve. So how do we do this? Well, we have some steps. We start by getting one side equal to zero. That's the first thing. Then factor completely, so that once you have one side equal to zero and factor completely, you can set each of those factors equal to zero, and then solve each of those new, nicer equations. So if we look at this first example, we try to go through the algorithm. We see that it says get one side equal to zero. Well, this side is zero already, so we don't have to do that. So that box is already checked off. So now we need to factor completely. In the previous lectures, we discussed factoring. So we see a trinomial here, and there's no a, or rather the a is equal to 1. So in that case, we have a nice little shortcut. We just look at the c value. And what are two numbers that multiply to be 2, that add to be 3? Well, 1 and 2 are. And as it turns out, we have this, again, the nice little shortcut says that this factors into x plus 1, because both of these factors over here are positive. So x plus 1 and x plus 2. So x squared plus 3x plus 2 factors into x plus 1, x plus 2. And now we can go to the next step. Since we factored, we can set each factor equal to 0. So x plus 1, we can set that equal to 0. That's one, because that's one factor. We can set x plus 2 equal to 0 because that's another factor. And then we simply solve, subtract 1 from each side. X equals -1 is one solution. And subtract 2 from each side, and x equals -2 is a solution. So I will do this for this problem, and I won't do it for the rest of this this section 3.2. However, we can check when you're dealing with solving equations. You can make sure that what you did was correct by plugging it back in to the original equation. So let's check each one of these solutions. So first, let's start with x equal to -1. Is that a solution? Well, when we plug it back into the original being x squared plus 3x plus 2 equals 0. So we plug in -1 squared, and we square it, plus 3 times -1 plus 2. And if this simplifies to 0, then we have 0 equals 0, which is a true statement. So -1 squared is +1. 3 times -1 is -3 plus 2. And then, does this equal 0? Well, 1 plus 2 is 3. 3 minus 3 is, in fact, 0. So does the 0 equal 0? Is that true? Yes. So x equals -1 is a solution. All right, what about x equals -2? That's the other possible solution we got out. Well, let's plug that one in. -2 squared plus 3 times -2 plus 2 equals 0. -2 squared is 4. 3 times -2 is -6. Plus 2 is, does this equal 0? Well, 4 plus 2 is 6. 6 minus 6 is 0, so yes, 0 does in fact equal 0. And that means that x equals -2 is also a solution. So both of the solutions that we got is true. So for these types of problems, these quadratics, you don't have to check. It's just could be a good idea. So what about this other one? Well, this other example, we have n squared plus 5n equals 3n squared minus 12. And what we're trying to do is solve. And to solve, we're using this method. We're trying to solve by factoring, so the method of factoring. And to do this, we have to use the zero product property, which means we have to get one side equal to 0 first. Get one side equal to 0 first. So how do we do this? Well, here I have stuff on both sides of the equations. It doesn't start out being 0. So here I have n squared and plus 5n equals 3n squared minus 12. What I'm going to do is take everything on this side and get it to the other in the sense of I'm going to get 0. I'm going to cancel this out by doing the same thing to both sides. So I'm subtracting n squared. Positive n squared minus n squared is cancel. Minus 5n from both sides. And now this whole side is 0. 0 doesn't always have to be on the right. Could be on the left. Again, 2 equals 2, right? And so what is 3n squared minus n squared? That's 2n squared. But the question is, what is negative 12 minus 5n? Are these like terms? Well, no, they're not. So what we can do, we can't really combine them, so we just write them out like so. And now we look at this, and we got one side equal to 0, so we're done with that part. We go to the factor completely portion. So we're going to start factoring this. Remember, towards the end of the factoring review, we said to try to pull out a GCF as possible. Well, 2 is prime and 5 is prime, and they're different, so we can't. So there's no numeric GCF. And then we have n squared n, and there's no n here, so we can't pull out a variable for a GCF. So we can't pull out a GCF. And since there's an a value, we're going to use the AC method. So AC is equal to 2, so that's the A, called the negative 5 the B, and the negative 12 the C. So again, with these values, the A, B, and C, you often want to include the negative if it's there. And what is 2 times negative 12? Well, that's negative 24. And what are two numbers that multiply to be negative 24 that add to be negative 5? Well, how about 3 and negative 8? Those multiply to be negative 24, but then they add to be negative 5. Then, what we can do, since they add to be negative 5, excuse the camera adjusting, we can separate the middle term. So 2n squared plus 3n minus 8n. Remember, the middle term just splits up. And then what happens now that we have 4 terms, we can do factor by grouping. So 2n squared plus 3n. Always between groups you have a plus. That means this negative 8n, the negative goes into the other group. And we just, since we're factoring by grouping, we now try to GCF factor each group. Well, 2 and 3 are prime, so we can just pull out an n. So we have 2n plus 3. Here, again, when you have a negative, you try to pull that out. So now we pull it out. And when we do, we have negative. We also try to pull out another number that divides into both 8 and 12. Well, 4 is the GCF there, so we can pull out a negative 4. And negative 8 divided by negative 4 is 2n. Negative 12 divided by negative 4 is positive 3. And now we have two terms that both share a 2n plus 3 in common. And then when we factor that out, we have the n and the minus 4 left over. And we have two factors that equal 0. And now we can move on to step 3 and set each of these factors equal to 0. And then solve. So minus 3, 2n equals negative 3, and divide by 2. N equals negative 3 halves is a solution. Over here we just had to add 4 to both sides. We have n equals 4. And these are our two solutions for this that satisfy the original equation from number 2. That concludes this lecture.